Well, good morning, everyone. My name is Dees Postma, and I'm here to talk to you about the catchability of fly balls. And to introduce my topic to you guys, I want to show you a memorable moment of baseball history, namely the catch made by Willie Mays in the 1954 World Series. Some of you might even actually remember this moment. And it's considered to be one of the most iconic plays in baseball history, amongst others because Willie Mays had to cover such a tremendous distance in order to successfully intercept the towering smash of Vic Wertz. Now what's interesting, after he was being interviewed about his performance, he claimed, "I knew I had the ball all the time." Which is remarkable, because how could he know? Was the guy just being cocky? Or was there actually something in the ball's trajectory and the action capabilities of Willie Mays himself that he knew that he was able to successfully intercept that baseball? Now, in considering this question, some of you might think about the optical acceleration cancellation strategy, also known as the Chapman strategy. And although the Chapman strategy has been invaluable in terms of locomotor control, it's limited when it comes to specifying the catchability of a baseball. Now why is that? Because the Chapman strategy only specifies catchability in two specific cases. The first being in which optical acceleration is successfully nulled. In that case, the fielder is standing already at the interception location of the fly ball, or the fielder is running in such a fashion that he can successfully null the optical acceleration in order to successfully intercept the baseball in time. From that, the fielder can see that the ball will be catchable. Now the other situation is when optical acceleration is not equal to 0 and the fielder is running as fast as he can in order to intercept the baseball. So although he is running as fast as he cannot null optical acceleration. From that, it's clear that the ball is not catchable. However, we feel that catchability can also be perfectly perceived if you're not running at your maximum running velocity. And this can be easily illustrated with a simple experiment. And when I say a simple experiment, I actually like to perform a simple experiment. So I'd like to have a volunteer from the audience. Yeah? You want to go stand here?
Wait, what am I volunteering for?
You'll find out soon enough. Just stand here, please.
It's gonna hurt.
No, here. Here, fun. Okay. So I'm going to throw this tennis ball in your general direction. I probably won't hurt you. And if you want to indicate to me as fast as possible whether or not the tennis ball I'm about to throw to you is catchable, that would be lovely. Yeah?
I'll do it.
Yeah, you can do whatever you like to catch it.
So I'm actually catching it or just indicating?
Both. You have to try to catch it, but you have to indicate to me when you know you're not going to catch it.
Because you'll know if you can't catch it.
Okay.
Yeah? Okay. Here it goes. 3, 2, 1.
Alright, this I cannot.
Well. Thanks for the effort. I'm afraid I dropped the mic on you guys. Okay, So it's unlikely that optical acceleration is the variable to be used by fielders to perceive the catchability of a baseball. So the question that remains is, what variable should it be? Well, in order to identify a variable that would specify the catchability of a baseball to a fielder, we figured we designed an experiment. And this experiment was quite simple. Actually, it was a more elaborate version of what I did to Dimitri. We had to your, let me see, here to the left, we had a ball projecting machine projecting baseballs to a participant standing here, and some projected fly balls were deemed to be catchable, others were deemed to be uncatchable. Fly balls were projected in front, and fly balls were projected behind the position, the initial position of the fielder. And we instructed the... Would you like to add something? Well, welcome, Siri. And we instructed the participant to try her best to intercept the baseball and indicate as soon as possible when she felt the baseball was uncatchable. I don't know where to go with this.
Is this the first time?
As a matter of fact, it is. I got the green dot here. So be gentle. So let's reiterate for a bit. Participants had to intercept baseballs and had to indicate whenever a baseball was uncatchable. Now, in practice, this looked a little bit like this. And the participants were able to move freely, and they could run as fast as they could, whenever they could. They just had to indicate whenever a baseball was uncatchable, and they were required to try their best to catch it. We recorded the experiment with an HD camera, and from the video footage we were able to digitize the XY position of the ball and the XY position of the fielder. And from these positions we were able to formulate a wide range of different optical variables that might be involved in the intercepting, in perceiving the catchability of a baseball. And our working hypothesis was that if some optical variable were to reach a certain threshold, that a participant would call no shortly afterwards. Now, we have examined a wide range of variables, and we didn't get the results we wanted. So we returned back to the drawing board. And after some elaborate discussions, we figured that fielders might actually be able to directly perceive the velocity they need to successfully intercept the baseball. We dubbed it required velocity. Now, mathematically speaking, what would be needed to calculate the required velocity? It's quite simple, actually. You need the distance to be covered, and you need to divide that by the remaining flight time. Well, if we were to follow up on this, this will lead us to some good news and to some bad news. The good news is we were able to fully optically specify required velocity. The bad news is this. It's quite the formula, to say the least. Now, I've taken the liberty to simplify it for you guys, but it's still quite the formula. Now, we know from yesterday's talk that intrinsic formulas might not be a problem. However, we cannot say for certain that this is actually the variable used to perceive the catchability of a baseball. However, higher order variables might just be used. Now, if we were to accept for now that fielders can directly perceive required velocity, what can required velocity do for us? Well, and now I go a little ahead on the results. Required velocity can separate trials that are catchable from trials that are perceived to be uncatchable. Required velocity can explain the temporal pattern of calling no. And required velocity can relate the maximum running velocity observed by in the experiment for different participants to the critical velocity, the velocity that separates the catchable trials from the uncatchable trials. Now, let's go to the first point. Here you see the trials of one participant, the required velocity of one participant plotted over time. The red lines represent the no trials. The black lines represent the trials in which the participant was able to catch the ball. And the black diamonds represent the actual moment the participant called no. And as you can see, with fair ease, we can construct a line that separates the no moments, or the no trials, from the catchable trials. And we call this the critical velocity, the velocity that separates the catchable from the uncatchable trials. And from this it can be seen that if the required velocity you need to successfully intercept the baseball were to exceed the critical velocity, you call no. Now, if we were to correlate the temporal pattern of crossing of required velocity exceeding the critical velocity and the temporal pattern of calling no, we get a scatter plot like this one, with on the x-axis the time of required velocity crossing the critical velocity, and on the y-axis the time of calling no. And this is done for all no trials of all participants in cases where the ball was projected in front of the participant. And the different colors represent different participants. And as you can see, we get a correlation coefficient of 0.73. Now, this is all nice and dandy, but if we do it for the back trials, we stumble upon a bunch of anomalous trials here on the left-hand side. Now, at first we were puzzled by this, but if we were to, when we examined a couple of participants, well, all participants are close, but in case of a couple participants, we found that if we were to construct a threshold of critical velocity, that for the back trials, which are these trials, the required velocity is higher than the critical velocity from the onset of the trial. Now, that in and of itself is not as much a problem if you were to find that participants would also directly indicate that a fly ball wasn't catchable. However, that's not exactly what they did. So, as to now, that's still a pickle. But if we were to examine these trials from further analysis, we obtain a correlation coefficient of 0.72 as well for the trials in which the ball was projected behind the observer. And we get, all in all, quite nice correlation coefficients. Now, if we were to correlate the critical velocity separating the catchable trials from the uncatchable trials with the observed maximum running velocity, that is the velocity we observe participants to maximally achieve during the experiment, we get a positive correlation indicating that participants who are able to run faster also have a higher critical velocity separating the catchable from the uncatchable trials. Now, with this model, I feel like we've made a promising step to explaining the affordance for catchability in intercepting baseballs. However, what's interesting about this premise of required velocity being perceived directly is that required velocity also provides a rationale for control. Because if you were to be able to keep your required velocity constant during the trial, you were to arrive at the interception location right in time to intercept the baseball. And so the affordances and the control aspect within this model are very compatible. And we hope to have made a first step to formulating an affordance-based control perspective on intercepting baseballs. And for now, I'd like to leave it at this. Thank you for your attention.